My name is Alden Reid. I am a sales engineer with Ribbon Communications, and I'm here to talk to you today about how to continue your zero trust architecture into your voice network. Some of you probably already heard of zero trust, and if you haven't, it's a new way of looking at your network security. It's pretty much as the name says, there's no trust granted to users, devices, or connections, regardless of where they're actually deployed. So no more granting permissions because you're connected within the protected enclave. You're going to treat every device, every connection as a potential threat and ensure the security there. The way the DoD is looking at zero trust architecture is to separate the areas of security into 7 pillars. You have users, devices, network and environment, application and workload, data, visibility and analytics, and automation and orchestration. Each pillar allows for specific focus on how to implement the requirements that together form a truly secure architecture for your network. Here's the catch. There's very little out there on how to continue that zero trust implementation to the voice side of the network. Modern voice deployments are running over the IP networks, but the requirements are completely different. For this reason, you need to put the security in place that's built for voice networks while providing the quality of service that's expected from a voice network. Ribbon has multiple products that fall into different categories to expand your zero trust architecture into your voice network. As you can see here are SBCs, PSX, our AS, and Ribbon Analytics products, and where they fit into the zero trust architecture. The linchpin of all of this is the SBC. SBC stands for Session Border Controller. The easiest way to think of an SBC is to think of it as a voice firewall. Like your traditional firewalls are typically deployed at the network boundary to the carrier, but unlike a traditional firewall, an SBC is purpose-built for real-time communications. So anything that isn't real-time communications is not getting through. Some of the key features an SBC provides are it acts as a back-to-back user agent, network address translation, or NAT for those of you that are familiar, transcoding, and encryption. The purpose of a back-to-back user agent is an SBC is going to break a call into separate segments. They're able to terminate, initiate, reinitiate, signaling, and SDP, or Session Description Protocol, for calls. What this allows is separate configurations, codecs, security, or certificates for different legs of the call. NAT's topology hiding, so devices on one side of the SBC don't need to know the network addresses on the other side of the SBC. This reduces the exposure to potential threats. Transcoding is the ability to connect a call where different legs of the call are using different codecs. The SBC will connect one leg of the call with one codec and translate the required codec of the destination or the next hop. Without this, the call will fail if a common codec can't be negotiated. Another key feature of the SBC is encryption. The SBC is able to encrypt and decrypt signaling and media for real-time communications for each leg. More of where session border controllers and firewalls are different are in how they operate. So they're both statefully aware, but the standard network firewall is operating on layers 3 and 4, while the SBC is operating on layers 2 through 7. The SBC is also doing full packet inspection on real-time communications traffic. This is an important differentiator between the two because the firewall is typically going to receive a SIP packet and see that the header says SIP and it's coming in on the correct port and let it through. The session border controller is going to look at the header information in that SIP packet and determine that it's a valid SIP packet. It's then going to terminate that leg and reinitiate on the leg to the next hop. This difference is even more noticeable when you turn on encryption because the firewall is going to do pretty much the same exact thing that it did before, but the session border controller is going to validate the certificate, decrypt the signaling, read the header, terminate on that end, and then initiate on the next leg with signaling that's encrypted for the appropriate certificates on that leg of the call. The added benefit of the decryption and re-encryption is that it gives us added insight for data on analytics for monitoring, troubleshooting, and security within your voice network. As I mentioned in the previous slide, the SBCs aren't going to pass anything that's not real-time communications because they just not built for it. The session border controller is designed to separate the different functions by processors. This allows the device to handle different aspects of its work without having an effect on the others. Security, call processing, encryption, transcoding, they're all done separately within the device. Where's the benefit? Our SBCs were Myricom tested, so they were hit with a telephone denial of service attack and never affected live traffic. This shows that you can be under attack and have confidence that you can operate your business as usual. Media ports are another big differentiator and why you'd want to use an SBC over a firewall. The media traffic in real-time communications is the voice you hear and the video you see. There's tens of thousands of ports available for you to use within the network. Firewalls have no way to be able to open and close those ports dynamically when they need to. So the only way to use those ports with a firewall is to leave those ports open regardless of whether you have traffic coming in or out. That is a huge security risk. When the SBC is doing packet inspection and validation, it's also negotiating the session description protocol within the SIP message. Within the SDP is a negotiation for which port the device is going to use to send media. So the SBC knows which port it needs to open for the media for that call. It's then going to negotiate on the other leg of the call which media port it needs to open on that leg. And as soon as the call is terminated and the buy message is received, then the SBC is actually going to close that port back down dynamically. This closes that port and makes sure that you can't use that as an attack vector within your network. So where would you deploy your SBC? Traditionally, they're put between the enterprise and the carrier. It provides a security between the internal network and the public networks. But that's not how Zero Trust works. With Zero Trust, it can and should be the boundary between your internal and external networks, but it should also be the boundary between your internal network endpoints and your PBX and cloud or cloud solution. It's called access registration. This deployment method, all users, regardless of where they're located, would have to register and route calls through the session border controller. The session border controller is only going to allow endpoints with the accepted encryption certificates to pass real-time communications traffic. So if the certificate's wrong, the phone's not connecting to anything. Once the certificate handshake has occurred, user credentials that can then be passed to the PBX or cloud solution, which would then provide services and capabilities assigned to that user account's profile. This method adds multiple benefits to your network. First, this protects your PBX, as a PBX is not designed to handle registration floods or telephone denial service. If they are overwhelmed, they go down. And the users assigned to the session manager that goes down have no capabilities. They will not be able to make 911 calls if they need to, or their phone's useless. The session border controller is designed to handle those types of attacks and can mitigate that attack on your PBX. The second added benefit is insight for network monitoring, troubleshooting, and security. You will have visual to every call from the endpoint to the SBC, to the PBX, back to the SBC, and to the next hop. This allows for a centralized view of all calls, not just the calls leaving your network through the SBC. We've mentioned the encryption a couple times already. The SBC was designed with encryption in mind. We have the ability to use IPsec or TLS for signaling and SRTP for media. So when you look at how the SBC is operating as a back-to-back user agent, the session border controller is able to keep a separate encryption for each leg of the call. The image on this slide depicts on how we can secure the calls between different legs of a call. So if you look at this like a hub and spoke, we have external users, internal users, the PBX, DISA, voice network, and Microsoft Teams, Zoom, Pexip, or any of those cloud service providers. Each of these spokes can have a separate encryption on the SBC. This can be from different CAs, sub-CAs, or just different certs within the same CA. The SBC knows which cert is used for which leg of the call and will ensure whatever comes in or out on that leg is encrypted with that cert. By doing this, each device that connects to the SBC has to have their certificate validated before they're able to make a call. And a key differentiator here is that ribbon SBCs do not lose any capacity when encryption is enabled on the device. So that's just something to keep in mind. So an SBC is great, but if you have a bunch of SBCs and a couple PBXs in different locations, a great way to simplify your policy and decrease your configuration time is to throw in a central policy engine. Ribbon's PSX has the ability to make routing decisions in your network through a static or dynamic policy. You can use least cost or best value routing to configure your route calls to their destinations based on how you prioritize your network or make changes through security mitigations. With insight from Ribbon Analytics, an attack focused on a single SBC can trigger mitigation sent back down to the PSX, which then uses them to make policy changes throughout all SBCs on the network, and it ensures the security across all of your network. Also, the PSX can actually query a home location register. The HLR is something that the carriers use to prove if a number is actually in a roaming state. And this is commonly used for spoofed calls. So it's one way of continuing the fight against those spoof calls. Another way it does this is it allows you to implement stir shaken into your network. Stir shaken is a signature-based validation mechanism, and it's critical when you start looking at spoofed caller IDs. Because we've all had a call where the caller ID says something like, it's your kid's school, and as soon as you answer that phone, they're talking to you about how your car's extended warranty is expiring. So you know it's not your school trying to look out for your vehicle service needs. You just got hit with a spoofed caller ID. So the idea behind stir shaken is to mitigate unwanted robocalls and bad actors who use caller ID spoofing to increase the chance of speaking to someone on the other end. So stir is the secure telephony identity revisited. It's a standard developed by the IETF that defines a signature to verify the calling number, and it specifies how it's going to be implemented into the SIP header. Shaken, the signature-based handling of asserted information using tokens, is the framework document developed by the SIP forum that provides implementation profile for service providers implementing stir. So stir shaken will be the basis for verifying calls, classifying calls, facilitating the ability to trust caller ID information. And on March 31st, the FCC mandated that all terminating voice service providers had to implement stir shaken into their networks by June 30th, 2021. And in September, they expanded that to the mandatory implementation to over-the-top service providers. With the use of stir shaken, you can create network policy to reject any calls that cannot meet the attestation standards within your network to help you reduce those calls. Moving a little further into the pillars, we get to pillar 5, data. Now, you might not think that there's a lot of data involved in a voice network, but with every call that hits an SBC, a call detail record is created. The call detail record contains about 250 standard fields and another 180 optional fields. There's a lot of data that can be derived from these records. So the SBC is happy to supply that information. Unfortunately, many of the typical systems used to collect data are more centered around your data networks. So Ribbon Analytics was designed specifically with the voice network data in mind. Within the data pillar, CDRs are securely collected from the session border controllers and correlated to an entire network-wide view to allow for quick monitoring, troubleshooting, additional security overlays for pillars 6 and 7. This is all done in a redundant cluster to ensure continuity of operations in case of a node failure. Once that data is correlated, we're able to use it for visibility and analytics. So discovery and baselining is one of the big pieces in pillar 6. And the ability to take a baseline of the voice network allows for flagging any usage outside of the normal day-to-day operations. Seeing random calls to high toll charging countries at 2 in the morning when the user typically calls the same 4 coworkers should be noticed. When these fraudulent calls occur, Ribbon Analytics can detect this through the CDR and flag for an administrator or automatically cut it off. Through machine learning, the longer the system is collecting data, the better baseline it gets of your network. Incident response and security orchestration automation and response, or SOAR, should not be limited to your data networks. All the information gathered through the CDRs tied to the signature-based and artificial intelligence of Ribbon Analytics brings that to the forefront of your voice network. Being able to detect things like telephone denial of service or robocalling within your network can trigger mitigation responses back to the PSX, to the SBCs to perform those mitigations and fix the issue. This can all be done without any human intervention. All this can be configured to meet the proper level of incident response needed within the network. Additionally, the ability to detect issues within the network and alert the administrator to the most probable cause of the fault reduces incident response times within your network. So network security is important, and change is hard, and disaster recovery is way harder. So this is why it's important to plan out your network deployments to include all aspects of the network, because you can't have zero trust if you don't implement it on your voice network as well. So this is what we do, and I thank you for letting me share some of that with you guys today, and I hope it gives you guys some insight that you guys can use.